Welcome to Math Defined. I'm Mrs. C, and today I'm going to show you how you can use counters to not only add integers, but to understand the rules for adding them as well. So let's get started. I'm going to start with this super easy expression. In fact, I'm sure that you already know that the answer to 6 plus 2 is 8. But the reason I am starting with this expression is to show you how to use the counters and so that you can begin seeing a pattern of adding integers that will help you understand the two rules that I'm going to show you in a few minutes. These two rules will help you add integers without having to use the counters. All right, looking at my expression, I have a positive 6 being added to a positive 2. To use the counters, I will represent each term of the expression with the counters. Let me show you. Starting with the first term of positive 6, I will place 6 positive counters first, like this: 1, 2, 3, 4, 5, and 6. Next, I will look at the second term in this expression, which is adding a positive 2. This part of the expression means that I will need to add 2 more positive counters: 1, 2. Now, the last thing to do is to count up all of the positive counters, and that will be the answer to this expression. So, counting up these positive counters, I see that there are 8 positives, so I know that positive 6 plus positive 2 is equal to positive 8. Now let's take a look at this expression. Negative 3 is being added to negative 4. Just like the last expression, I will use the counters to represent each term in this expression. So I will bring down 3 negative counters to represent the first term of negative 3. 1, 2, 3. You will notice that the positive counters were yellow for the previous expression, and the negative counters here are red. Then I will look at the next term in the expression. This part of the expression means that I will need to add 4 more negative counters. 1, 2, 3, 4. Now we just need to count up all of the counters, and that will be the answer to this expression. I count up 7 negatives, so I know that negative 3 plus negative 4 is equal to negative 7. Now, this expression is a special one. Let me show you why. The first term is positive 1, so I'll bring down 1 positive counter. Then I need to add the second term of negative 1. So that means that I will need to add 1 negative counter. So now our next step would be to count up the counters. But I don't have all positives or all negatives like I did before, and this presents a problem because I can't say that the answer to this expression of 1 plus negative 1 is equal to 1 positive and 1 negative counter. That would be a very confusing answer. So let's go back and look at the expression again, and you see an addition sign followed by a negative 1. Let's just drop the addition sign. Now that the addition sign is no longer there, I can rewrite the expression without the parentheses around the negative 1. So now I have 1 minus 1, which we all know is equal to 0. And since the expression 1 plus negative 1 is the same as 1 minus 1, it is also equal to 0. So from this example, you can see that a positive counter paired with a negative 1 will give you a value of 0. Basically, they just cancel each other out. And for this reason, this positive-negative pair has a special name called a zero pair. I'm going to show you how to manage these zero pairs in the next expression. If you're liking this video so far, share it with a friend, give it the thumbs up, click the subscribe button along with that notification bell. Doing these things really does make a huge difference for the channel. And if you're a returning viewer of my channel, thank you so much for your support. It really means a lot. All right, moving forward. Here we have positive 5 plus negative 7. Again, we'll start by bringing down 5 positive counters. 1, 2, 3, 4, and 5. Next, we will need to add negative 7, so we will need to add 7 negative counters. 1, 2, 3, 4, 5, 6, and 7. You'll notice that I lined up my positive and negative counters so that I can easily cancel out those zero pairs. Remember, 1 positive counter paired with 1 negative has a value of 0. So now I will cancel out all of my zero pairs going from left to right. As you will see, we have 1, 2, 3, 4, 5 zero pairs. The last step is to count the number of counters left, and that is your answer. I see 2 negative counters left, so 5 plus negative 7 is equal to negative 2. Now let's try this one. We start off with negative 1, so I will bring down one red or negative counter. Then my next term is adding a positive 7. So I'll need to bring down 7 yellow or positive counters. 1, 2, 3, 4, 5, 6, and 7. Next, I need to cancel out the 0 pair. The last thing to do is count the number of counters that remain. I count 6 positive counters, so the answer to the expression of negative 1 plus positive 7 is equal to positive 6. Now that you've practiced adding integers with counters, it's time to look at the 2 rules for adding integers. I think you will find them to be pretty straightforward and easy to understand. The first expression we looked at, 6 plus 2, both of the integers were positive, so all we needed to do was add them together and keep the positive sign. Then the second expression was negative 3 plus negative 4. Both of these integers were negative, and the answer was negative 7. Do you see a pattern here? If you do, you have a great eye. The rule is that if you have integers with the same signs, then all you need to do is add them together and keep the sign. So again, positive 6 plus positive 2 equals positive 8. And negative 3 plus negative 4 equals negative 7. Then we looked at expressions where the integers had different signs. We looked at negative 1 plus 7 and 5 plus negative 7. The rule here is a little different. When the integers have different signs, you subtract and keep the sign of the larger integer. So looking again at negative 1 plus 7, we need to subtract 7 minus 1 to get 6, and then we need to decide if this 6 is positive or negative. Since 7 is the larger number and it is positive, our answer of 6 will be positive 6. Now let's look at 5 plus negative 7. We need to subtract 7 minus 5 to get 2. And then again, we need to decide if this 2 is positive or negative. Since 7 is a larger number than 5 and 7 is negative, our answer will be negative 2. Let's practice these rules. Here we have the expression negative 3 plus negative 2. Since both of the integers have the same sign, all we need to do is add them together and keep the negative sign. So 3 plus 2 is 5, and since both of the integers are negative, our answer is negative 5. Now let's use the counters to check our answer. We begin by bringing down 3 negative counters, 1, 2, 3. The next term of negative 2 is being added to negative 3, which means that I will need to bring down 2 more negative counters, 1, 2. I'll count the number of counters I have, and that will be the answer. There are 5 red counters, so my answer is negative 5. Now we have the expression 6 plus negative 5. Since each integer has a different sign, we will need to subtract them first and then decide if our answer will be positive or negative by looking at the larger number. So 6 minus 5 is 1, and positive 6 is the larger number, so our answer will be positive 1. Again, let's use the counters to check our answer. We begin by bringing down 6 positive counters, 1, 2, 3, 4, 5, and 6. The next term of negative 5 is being added to positive 6, so I will need to bring down 5 negative counters, 1, 2, 3, 4, and 5. Next, I will cancel out the 0 pairs. 1, 2, 3, 4, 5. Looking at what is left, I see just 1 positive counter, so I know our answer is positive 1. Let's practice another expression where both integers have a different sign. Again, since the signs are different, I will need to subtract them first and then decide if the answer is positive or negative. So 5 minus 3 is 2, and since 5 is the larger number and it is negative, the answer will be negative 2. Using the counters, we will start with negative 5. I'll bring down 5 negative counters, 1, 2, 3, 4, 5. Looking at the term, positive 3 is being added to negative 5. So I will need to bring down 3 positive counters. 1, 2, 3. Next, I'll cancel out my 0 pairs. 1, 2, 3. Now, all I see are 2 negative counters. So the answer is -2. I hope this video helped you out. You can check out more of my math videos at Math Defined. And until next time, thank you so much for watching.